see walls in the traditional engineering sense of creating something that holds a roof up. I see walls in the sense of a skin that can breathe, expand, shed, sweat, grow. So when we think about these technologies, where I could see us perhaps collaborating is because I'm not an inventor, but if we're going to shift the collective perception of technology, we have to have biomimicry, and we can use form-based biomimicry in your example to showcase, to show people the story, to get them into the story of biomimicry, to see the sexy example and say, well, that's interesting, that emulated nature, and then as soon as they get that, then they see nature's doing all of the same things that we are in the same context, but in a very different way. Never would they have the problems of dealing with these toxic chemicals in a microchip plant, or because it wouldn't do that. So to answer that question, that was an interesting aha moment for me. But to answer your question, the biomimicry incubator space is a bottom-up approach that I'm taking in Canada. So to shift our perception, I'm working top-down and bottom-up. Top-down is working with landowners and architects to apply principles of biomimicry to housing design and land development. That's my focus. So I work with city builders, landowners, politicians in Canada. And that's fun for me because it's trying to shift this existing system that we've created. So we've all inherited this system. This system's been based on a paradigm from long ago. Newtonian thinking, religions, all these different things have resulted in what we have today. And that's fine. The things that we can do are incredible, but we know that it's not sustainable. So if we can work and start to play with the existing systems, applying these sustainable technologies, that will get us somewhere. But what I'm really excited about is the bottom-up disruption that can be created through this biomimicry incubator space, where people are creating technologies from a new paradigm. So it's fundamentally about paradigm shifting and allowing young or whoever, creative people, to tap their creative potential, step into a new source, I call it, of creativity. And when you build from that paradigm and apply it to this technology, it will be disruptive because people will see it and say, that looks very different. It's because it comes from a different source. It's not our own intelligence. It's coming from a natural intelligence or even a spiritual intelligence that I think will disrupt the system in a very powerful way. So those are my two approaches, and the Biomimicry Commons is our first attempt at this. So it's an incubator, educator, disruptor space where I'm teaching the methodology of biomimicry, but also the methodology of getting people into their creative potential, accessing people's creative potential so that they can use biomimicry to create something that's never been seen before. One of the partners, Jay Harmon, I don't know if you know him, but he's in California. He's a biomimicry technologist, and he built a Pax impeller which pulls water, emulating the bathtub vortex, if you've seen that. He was inspired by kelp. So kelp in a coastal region, when the wave crashes, will turn. And he was interested in why. And it's because nature moves with the flow of its environment. And so instead of getting ripped out of the ground, the kelp intuitively understands to curl so that when the wave crashes, it doesn't pull the kelp off the ground. So he took that idea, that spiraling idea, which is ubiquitous in nature. Our skin pores have that Fibonacci spiral. Our ear hole has that Fibonacci spiral. You see all the plants, the patterning of plants is a Fibonacci spiral. He took that spiral and made an impeller that's pulling fluids, and it's a much more efficient fan or boat propeller or water pump than any propeller that we have, and it doesn't have the cavitation that is caused when you're pushing water. You'll have many explosions on the propeller, and that wears down the propeller because you have such great friction. But he's pulling water with a great efficiency, and we're partnering with him and he's offering to bring the technologies to Canada, because that's an example of a form where it looks like something we've never seen before. It doesn't look like the old technology. It's beautiful, it's simple, and it allows us to enter into the space of biomimicry, into that story of shifting our perception. So that's fundamentally what I'm up to, is trying to shift our perceptions through the development of technologies and the kind of disruption of existing systems.
And how receptive have architects been to what you have been offering them?
I'm having, for example, so I'm an engineer actually, I'm not an architect. The architects have been coming to me when I tell them about biomimicry. And when I tell anyone about biomimicry, there's an intuitive understanding that clicks, I see. People get it at a fundamental level. Yes, of course, nature has incredible forms, processes, and systems. And it's doing it very differently than humans are. It's cleaning air, it's pumping water, like a tree is pumping water without mechanical devices or electricity, 300 feet sometimes. That's incredible. So when I talk to architects, they intuitively understand. But I also think they get the marketing side of it too, is I truly believe it's the next wave of sustainable thinking. It is the next paradigm. And I do believe everyone else understands too, because there is no greater sustainable system on Earth than nature. It's been around billions of years. So you can't argue that. You can't refute that that's the next sustainable thinking if we copy nature. And architects are excited because where we stand now, the challenge is people don't know how to apply biomimicry. When I say to an architect, I do biomimicry, they'll say, what does that mean? And that's where the relationship begins, because the architects I'm working with, like B+H architects in Toronto, asked me to join their team because they want to be biomimetic. They don't know how it applies, they just know that they want to apply it. And that's my role, is to work with them. I met with Purple Ink Studio last night in Bengaluru, a great group of architects. And they are very interested in that idea of biomimicry as well. So it comes, I think, intuitively from a place of like real understanding that nature has something to teach us, and architects have the skills to translate that to design. They have the creative ability to pull those two worlds together, and I feel like I sit in the middle, where the way I see myself is I speak on behalf of nature, or I communicate for nature because nature can't speak English. So my PhD was all about understanding ecosystem behaviors, because I want to know how can we translate that into engineering design.
We talked about design. A lot of the application of biomimicry is to do with products and not with settlements and homes and buildings and such. So how would designers respond to this? One question. The other is, when you listen to someone like Professor Bala, who is breaking down elements, understanding how they behave, and then connecting, into new synergies and forms, keeping an eye, of course, constantly on human ecology and application.
Yeah.
Finally, it's not about ecology. No one's going to accept that.
Yeah.
So how do you see these two things? Design on one side, and people like him who are coming from this understanding of elemental behavior patterns of components of chemistry and of physics.
Well, that's the interesting part, is it's a very Newtonian kind of history. Newton helped us break the world down into chunks, and then we could measure those chunks and put them into new configurations that made us a really powerful species. Biomimicry is systems thinking, so what you're doing is taking these parts and putting them into new patterns. Now, what if that whole process was influenced by nature? You could put them in patterns that are modeled after a sustainable kind of way of doing things. So we've just been putting things together based on our own
You don't have to be polite to him. You can go ahead and...
No, but I think it's valuable to respect where we've come from, because that's what's going to ultimately get us to where we need to go. So Newton, I don't think it's a bad thing that we can do the things that we do. We've just gone off course because for example, we can use and harness energy unlike any other organism on the planet. Once we learned how to control fire, we made materials and environments for our own good. And now we're learning that we've outgrown our system and we've become unsustainable in that path. So it's so important to have people like Professor here who have that intelligence to be able to put these things, break them apart and put them in new configurations that are informed and modeled after nature. The designers, the products, like I said, that's a sexy idea. The urban ecologies, the ecosystem stuff, that's the complex thinking that I think the next generation gets. I think they can actually put things together in very creative ways. They can deal with complexity a lot in a new way. And I've noticed that teaching, even with the professors who are retiring, I hear often that the next generation is like, they're hopeless, they're not smart. And I think what we're missing is actually the beauty and the brilliance of their intelligence might not be from a historical perception. It might not be historical brilliance. They see brilliance, their brilliance is in how they can deal with complexity and put things together unlike we've ever done before. So that's why the Commons is an education space too, is because I want to tap into that brilliance. And then we put things together, we can break it apart and put it together in a biomimetic or a bio-inspired way and then it'll, I mean, we can make products, but my whole reason I'm working with landowners and city developers is because I want to shift systems.
Jamie, could you talk a little bit about the Harare building, which is biomimetic?
Yeah, the Harare building is, Mick Pierce is the architect, and he developed it based on a termite mound. It has actually a couple biomimetic properties. And before I say that, I will say a lot of people do biomimicry without knowing it, like you were saying. So right now, for me, biomimicry is a lot of storytelling. Mick Pierce consciously used the termite mound, and what the termite mound, its context can fluctuate from 40 degrees to 2 degrees in 24-hour period. Very hot days and pretty cool nights. Inside the mound, the temperature maintains a constant temperature of 32 degrees, plus or minus 1 degree. So he was interested, how does it do that without any pumps, gas, energy, and it's all through the ventilation system. So first of all, the materials that they use to create the nest are just dung, saliva, and soil. So they make a natural material, and it's very porous, so it breathes on its own. So already you've got air transfer in the material. To add to that, the termites will actually create tunnels in the section above the ground. And those tunnels will also start to support ventilation. They're cleverly adapting those vents throughout the day depending on wind patterns. So, like, I whitewater canoe, and when you go down a rapid, you can always hang out behind the rock because the water's creating these eddies and it's curling back. So the same principle with the termite mound. The mound will positions its holes in such a way that it eddies around and will actually suck air in like a vacuum and pull it up. To support that air transfer, they also harvest fungus at the bottom, at the root of the termite mound. So that methane gas that's created is floating up and pulling air as well. So you're constantly pulling and recirculating air, and that fresh air will be pulled in and dropped down because it's more dense, and allow fresh air, and then it'll pull the hot air up. So it's a little bit about adaptive strategies and really air transfer. And so what Mick Pierce did is he created a perforated shopping center. And the other thing that he did that's biomimetic is that he made a lot of microclimates. So microclimate meaning he made a lot of, there's an Indian word that I just learned last night. Oh, the jolly.
Jolly.
Yeah. So he used that kind of same technology where there's lots of shading, and that shading will create little microclimates, so you'll get little wind patterns, and that's what nature is very good at the micro scale. It does work system scale, but at the micro scale you'll see even elephant skin, the wrinkles of elephant skin allow moisture to get trapped into the ridges and to allow more ventilation and cooling, natural air conditioning. It's the same idea in the shopping center. So it's perforated, pulling air up and creating this kind of stack effect. But at the same time, at a micro scale, he's got lots of shading or lots of shadows that actually create a microclimate that's pulling air in and creating the ventilation. So that's how that works.
I have a question. I go to a remote park away from my house, 3 kilometers one way to reach that park. And this year it rained very heavily in Bangalore.
Yeah.
And there's an anthill out there. And I was wondering why I didn't get washed off. So out of curiosity, I went and tapped it. And I found the structural strength was phenomenal.
Yeah.
So what's the reason that it didn't kind of melt off in the heavy rain?
Which structure? The termite mound?
Yeah.
That's a good question. I don't know. I know with ants in their mound, when they create the little turrets and you can pour water.
Adhesive bonding of the saliva.
Yes, yeah.
They coat it with that, the ants do,
Right.
and the termites do. And so on the outside, it's sort of waterproof.
Yes.
And it doesn't, unless you do something violent to it,
Yeah.
it doesn't.
No, I tried to do that, it was very tough.
Yeah,
Like a wall.
What we normally do is that a lot of our practice is also based on a lot of biophilia.
Yeah. Yeah.
But actually with the ants, it's that they are bigger urban designers than we think. They place themselves in the rain shadows most often. As of course they're sensitive to moisture, they're sensitive to what is below the ground too. but they plan and place themselves in a way that it's most often in rain shadows.
Mm-hmm.
So that way they get protected. You can see smartly the way if you take a floor of a forest or a floor of a park, you might see that it is all protected
Mm-hmm.
in some form or the other. And the way they actually work with some leaves also hold water for a longer period of time before
Mhm.
they drip out. So they start sheltering themselves that way.
Mm-hmm.
That's,
Yeah, and at an ecosystem scale, like for biomimicry at a system scale, a forest, I mean, we create our environments to have somewhat stable conditions. That's why we have an air conditioner in here. A forest is doing the very same thing. It doesn't like to be disrupted from environmental changes. So that's a great example of like a forest canopy will dissipate all the rain, so the energy that hits is very light. At the same time, it's creating a microclimate in that, so you have pretty constant temperatures, humidity, wind pressures, and that's why when you cut a tree down, if you look at a forest, especially in Canada, you don't see one tree that's 600 feet above the other ones. Like how our economic system kind of runs on that model, who can grow the tallest, the fastest. A forest intuitively has an understanding that it works better if we're all the same height, if we have that strong canopy, because as soon as you cut a tree down, you now have a hole for that wind to come in and make a little bit of disruption, a little bit of noise. So a termite mound built in a context, I mean, a lot of them might be in the desert, so they have to be rigid and they have to be strong. Or they'll be in a more arid region. But in a forest, you have that dissipation and you have so much creativity in terms of organism design because you have those constant temperatures. So the one thing Janine, she said to me when I first met her is, if you want to see some of the craziest designs, go to the most uninhabitable places, to the deserts, to the depths of the ocean, because organisms go there because there's no predators. But they go there, they have to be incredibly clever and inventive. So that's where you'll find some really interesting ideas. But if you want to know how to build a community, go to a forest. And that's where you'll see sustainable systems. That's where you'll see diversity, you'll see inclusion, you'll see everyone's working, there's no unemployment in a forest. And everyone has the opportunity to innovate, and they have to innovate. There's that, what I call coopetition. There's cooperation. Trees will share and distribute resources through their mycelium. They'll donate food and water, but at the same time they're promoting competition because competition is good for evolution. So that's why the incubator space and all these incubator spaces, yes, we should have competition, but at the same time, let's give the resources to these spaces for people to have that opportunity to self-organize and come up with new ideas.
So we have constantly this debate in our practice too. That is, you have biomimicry, then let's say extended arms or the bottom-up arms are biophilia, and the entire system, as I say. The divide always has been that one, you drive technology to the highest level.
Mm-hmm.
So that's what, let's say, technologists would look at biomimicry from.
Mm-hmm.
We've been always kind of seeing at practice level that whether we can look at it from the passive right approach.
Yeah.
So how we can blend the passive right side of architecture or design to mimic at the biomimicry level.
When you say, what do you mean by passive?
So what happens otherwise, let's say a lot of what we discussed earlier was all technology driven.
Right,
I can add
yes.
this technology, I can add another technology. Then
Yeah.
it becomes technology heavy.
Yep.
And usually with technology, there is a problem that it's like the cell phone, right? Every second or third day you have a new model, new technology, and this becomes outdated.
Yeah.
But architecture or the built environment survives 50, 60 years or 100 years,
Yeah.
as much as it wants to survive. So how does the mimicking
Yeah.
and how does the blend of actually passive? So whatever technology you add, it doesn't disrupt the build.
Right.
It just enhances the build.
Yeah.
So that's the debate we constantly have.
Yeah.
So we kind of force feed in the way we do architecture from largely being passive right.
Yes.
So when we start placing things passive right,
Yeah.
it could be any number of mandates. Do you see that as a gap? Do you see from a biomimicry, biophilia,
Yeah.
biotechnology point of view?
No, I actually see them all very complementary.
Okay.
And I agree with you. There's like a structural form will give the basis for everything else to grow. So if you can build a form in a passive way that's very intelligently attuned to its environment, that's why I'm very excited with 3D printing, for example. As we're starting to 3D print forms and structures, we can do it using computer modeling that's very attuned to environmental conditions and stresses and strains, so that you don't have to create the square boxes that we have been doing in the past. And so once you have your skeleton, just like the human body, then you put the layers on top of that. The skeleton gives the form for everything else to grow, so then you can put the technologies, you can do the biophilia, you can have the adaptive facades or kinetic facades, you can have these things that adapt to the environment, but like our skeleton, it doesn't change that much, whereas our skin is changing quite frequently, or our hair, or all these exterior things.
Great. Fascinating. I know this conversation can go for more.
Yeah, I can talk for too long, yeah.
I think we should close this end of it. And
Yeah.
like I wrote to you, we'll see how we can take some part of it.
For sure, yeah.
Thanks for that one.
Yeah, thank you.